Bismillahirrahmanirrahim. Viewers, as you know, we are solving exercise 2.1 of chapter 2 of second year math. Here we are going to solve question number 113 part, x raised plus 40. In this question, basically we have to find the derivative using definition. For this, we will assume it y x raised per 40. And we have to find the derivative dy by dx. And how can we find the derivative dy by dx using the definition? We have to add the changes in the variables x and y. As you know, delta x is the change. We denote the change delta x by delta x in the change. Delta x is the change in the x, and delta y is the change in y. We will add these changes in these variables. How can we add these changes? Next step is add delta y, which is the change in y, and add delta x, which is the change in x, Keep in mind, do not disturb the basic formation or basic structure of the function. What is the basic function of the basic format or structure of the function? That is x raised per 40. What you have to do, without disturbing x raised per 40, you just have to add delta x in x. Now, next step is keep delta y on the left hand side and take y on the right hand side. This is the next step. And then x plus delta x raised per 40. Put the value of the y, which is x raised per 40. What is the next step? Add this by delta x. Add left hand divide both sides, left hand side and the right hand side, by delta x. Quickly assume x raised plus 40 as y, and then add the changes in y and x just like here. And then simplify, keep the delta y on the left hand side and take y on the right hand side and apply the value of the y, and then divide both sides by delta x. These are the steps. What's the next step? We have to take the limit as delta x approaches 0 on the right hand side, on the both sides. Take limit delta x approaches 0, delta y over delta x, limit delta x approaches 0, x plus delta x raised per 40 minus x raised per 40 over delta x. These are the steps. After dividing both sides by delta x, we have to take the limit delta x approaches 0. Now, on the left hand side, this expression limit delta x approaches 0, delta y over delta x will become dy by dx, which is the derivative of y with respect to x. But on the right hand side, we are in trouble, because when we put delta x approaches 0, this denominator will behave infinity or indeterminate form. We cannot put here because division by 0 is not allowed. So we are in trouble here. What we have to do, before applying the limit, before putting delta x is equal to 0, we have to simplify the numerator in order to cancel this delta x. And how can we simplify? Obviously, we will apply binomial theorem on this expression. What is the binomial theorem? Let me write for you binomial theorem. You have read it in the first year class, chapter number 9. Chapter number 8. A plus b raised per n is equal to a raised per n plus n into a raised per n minus 1b plus n into n minus 1 over 2 factorial a raised per n minus 2b square, and so on, plus b raised per n. What happened here in the binomial theorem? You start from a raised per n, and gradually power of a is decreasing, and you finish it at a raised per 0. And you start here from the power of b 0, b raised per 0, and gradually you increase the powers of b and you end at b raised per n. This is the symmetry, starting from a raised per n and ending at a raised per 0. Starting from b raised per 0 and ending at b raised per n. And these are the binomial coefficients here. n into n minus 1 over 2 factorial. And you can guess what will happen for the third term, for the fourth term. N into n minus 1 into n minus 2 over 3 factorial. N into n minus 1 into n minus 2 over 3 factorial. And here we will have a raised to power n minus 3 and b cube. But once again, keep this symmetry in mind. The power of b is subtracted from n, which is the power of a. This will be in every term. Next term will be a raised to power n minus 3 b cube. What is it indicating? B ki power 3, that is being subtracted from the n, which was the power of a. This is once again symmetry. Now turning to the problem here. Here n is 40, a is x and b is delta x. Obviously applying this binomial theorem here, what will happen? X raised per 40 plus 40 x raised per 39 into delta x, and then 40 into 40 minus 1 over 2 factorial x raised per 38, and obviously delta x square, and so on. Last term will be delta x raised per 40. This is the expression obtained by binomial theorem expansion. When we expand this using binomial theorem expansion, we get this expression. Now we have here minus x raised by 40 as well, divided by delta x. Now what will happen, as it happened in the previous questions, x raised by 40 will be cancelled out with this minus x raised by 40. And you will have here dy by dx is equal to all the terms remaining contain delta x. Look at here. Here we have delta x. Here we have delta x square. Here we have delta x 40. All the terms contain delta x. That's why we can take delta x common from the numerator. Now, using limit delta x approaches 0 and taking common delta x from all the terms of the numerator, when you take delta x common from here, what will you have? 40 x raised to power 39 plus 40 into 40 minus 1 over 2 factorial x raised to power 38 delta x. When you take delta x common, you will have here delta x, and up to so on. Delta x raised to power 39 shabash divided by delta x. Now this problem is resolved here because this delta x in the denominator was disturbing us, and that is going to cancel out with the numerator delta x. And we have here dy by dx is equal to limit delta x approaches 0, 40 x raised per 39, 40 into, obviously this was no need to write here because we can put here delta x, obviously delta x raised per 39. Now due to absent delta x from the denominator, we are able to apply the limit. We can put the value delta x 0. Now when you put delta x 0, all the terms except the first term will become 0, because here this term involves delta x and all the remaining terms involve delta x. That's why these terms will become 0, and ultimately we will have 40 x raised power 39 derivative of x raised plus 40 is equal to 40 x raised plus 39. We could also solve this question using the power rule of differentiation, but here we were asked to find the derivative using definition. Hopefully you have understand. Now we start next part of the question. Next we solve 14th part of question number 1. Once again we have to find the derivative of x raised power minus 100 using definition. Okay, write y is equal to x raised to power minus 100, which can be written as 1 over x raised power 100. What we have to do, we have to add change in y, delta y in y, and change in x, delta x in x on the right hand side. तो x raised पर minus 100 था, तो when we write it in the denominator, obviously power sign of the power will be changed. Now what you have to do, next step is keep delta y on the left hand side and take y on the right hand side. What is the next step? Use the value of y. What is that? That is 1 over x raised per 100. Now before dividing both sides by delta x, just simplify it. Take the LCM. LCM of these two terms will become x plus delta x raised to power 100 into x raised per 100. Obviously this will become x raised per 100 minus x plus delta x raised to power 100. This is delta y. What we have to do now, we have to divide both sides by delta x and then applying the limit. Before doing this, we can simplify this first. And how can we simplify this first? We can use binomial theorem expansion on this expression. This will give us x raised per 100 minus x raised per 100 plus 100 x raised to power 99 into delta x plus 100 into 100 minus 1 over 2 factorial x raised to power 98 and delta x raised to power 2 up to so on plus delta x raised to power 100. This is by using binomial theorem. Divided by x plus delta x raised to power 100 into x raised to power 100. Now what can you do here? You can multiply each term by the negative sign and you will have here delta y is equal to x raised per 100 minus x raised per 100 minus 100 x raised per 99 and 99 into delta x, obviously minus 100 into 100 minus 1 over 2 factorial x raised to power 98 delta x raised per 2 and so on up to delta x raised per 100 divided by x plus delta x raised to power 100 x raised per 100. These two terms will be cancelled out and once again you see here each term of the numerator contains minus delta x. Therefore we can take minus delta x common from the numerator and this will become, taking minus delta x common, we will have here negative sign is taken common and this will give you positive sign 100 x raised per 99. Obviously from here once again you will have positive sign 100 into 100 minus 1 over 2 factorial x raised per 98, and look at here, because delta x has taken common, therefore this delta x square will become delta x, because one power of delta x has been taken common from the numerator, from each term of the numerator. Likewise, you will have here delta x raised to power 99, and on the denominator you will have x plus delta x raised to power 100, x raised to power 100. Now when you divide both sides by delta x, this delta x will be cancelled out. You can skip this step as well. Okay, dividing both sides by delta x, we will have minus delta x into 100 x raised to power 99 plus 100 into 100 minus 1 over 2 factorial x raised to power 98 delta x plus up to so on delta x raised to power 99 divided by x plus delta x raised to power 100, x raised to power 100, and obviously we have divided both sides by delta x. Now this delta x will be cancelled out, and now we are in position to take the limit delta x approaches 0 on both sides. Limit delta x approaches 0, delta y over delta x, limit delta x approaches 0. On the right hand side we have minus 100 x raised to power 99 plus 100 minus 1 over 2 factorial x raised to power 98 delta x, and up to so on delta x raised to power 99 divided by x plus delta x raised to power 100 into x raised to power 100. Now there will be no harm if we put delta x approaches delta x in place of delta x 0, because we don't see in the denominator delta x. Here we see in the denominator delta x, but that will not make the denominator 0 when we put delta x is equal to 0. But here this delta x will make the denominator 0 when we put delta x is equal to 0. Therefore it was essential to cancel this delta x from the denominator. That's why we did, and now we are in position to put the delta x 0. Okay, left hand side, as you know, will become dy by dx, and applying the limit 100 x raised to power 99. Obviously each term of the numerator has delta x, that's why when we put 0, all these terms will become 0. On the denominator, obviously here we have to put delta x 0. This will give you x plus 0 100 into x raised to power 100, and now this will give you minus 100 x raised to power 99 divided by x 100 x raised to power 100. This will become minus 100 x raised to power 99 divided by x raised to power 200, and this will give you minus 100 over x raised to power 200 minus 99. What will be the result? Minus 100 over x raised to power 101. This is the answer of this question. This is the answer of derivative of this question. There is another form which you can use here. What is that? Minus 100 x raised to power minus 101. Hopefully you understand the lecture, you understand all the procedure. If you have any questions, you can ask me in comment box. Thank you.